So thank you. My name is Andrus Kuus, and for the last 23 years I have been working in software industry. I started in '95 as a programmer. At some point I was promoted to a project manager and then to unit manager who had to oversee several software teams. I really didn't like that, so I became a management dropout and returned to building software as analyst. This was about 10 years ago. I worked for a company called Proekspert, as Pirusa already said, about 150 people, and one of the oldest IT companies in Estonia, actually. We focus mostly on creating digital products and services for other organizations. In recent years, we have also started the product development of our own. Currently, I work as a team lead for one of those products. It's a tool for data scientists, as Pirusa already said, and it's called Kogu. We aim to solve reproducibility and information sharing problems for data science teams. So if this sounds interesting to you, I'll be around later and we can have a chat about that. Today, I will tell you 3 stories about the principles I'm following in my work, and I believe that these principles are also relevant in the field of data science. So let's start. The first story is about my uncle. My uncle is a woodworker, and he builds furniture, custom designs, all the projects are unique. There are rarely less than 6-month queue for his work, so he's a busy guy. Often he has to say no for his new jobs because he really cannot deliver in the reasonable time frame. So he also has a son, also a woodworker and also making furniture. So to me, it makes really good sense for them to work together and share the load, but they are not doing it. So when I asked my uncle why, he answered that their ways of working are really different and they are not matching that well, that he gets frustrated when he has to work together with his son, and that his tools get misplaced and they have different tempos and they don't agree on things. So why this should be relevant to you? I think it's quite safe to assume that in few years you will all be working within data science teams. And it's quite safe to assume also that a lot of your teammates will be people fresh out from university who really don't have much experience in working as a team. So if you don't want to end up in a situation as my uncle, then I would suggest that you will deal with that. First, you have to acknowledge that teamwork does not get better by itself, nor can somebody else solve the problem for you. So you have to deliberately spend time on improving the way how you work together. Important step in accepting this responsibility is to create a habit of discussing why and how you do things in your teams. So the next story is from my own personal experience. In the beginning of 2000s, we had to take over the development of the system that calculated bonuses for the customers of the large company. As usual, in these cases, there is a set of project assets that is handed over to a new team. The most important of these assets is a source code. In our case, they said that the source code was to be found from the corporate workstation. When we got access to the computer, we found the code from there indeed. In fact, we found several versions of the source code located in different folders. It was unclear which one of these we have to use, and soon we found out that there was also another workstation that contained the code. So eventually, we ended up with having 7 different folders with 7 different source codes. We did all what we could think of. We analyzed it, we ran comparative tests, we cross-referenced the documentation, but unfortunately, it turned out that none of these folders contained the code that was running in live. So we did something quite unusual. We patched the sources together from the content of several folders and added a code that we got from decompiling the live system. This code, of course, was our best guess, but we were lucky and it worked. So this wasn't a small work in itself. I'm talking about weeks here, if not months, and it was only needed for us to get up to the point where we could proceed in making the improvements to the system. So there is something for you to think of. There's a quote from Martin Fowler: "Any fool can write a code that a computer can understand. Good programmers write code that humans can understand." I would elaborate this principle to more than just writing a code. Strive to make all your work understandable to other people. So choose the tools and practices that help you to achieve clarity and understandability. Refuse to use the tools and practices that make it harder. So to keep track of things, choose task management system instead of Excel sheets that are sent over email. Choose wikis to store the documentation and knowledge instead of Word documents, which are really hard to update. Choose version control instead of multiple copies of folders in corporate workstations. So have clarity in mind when you're choosing your tools and ways how you work. Since we're getting closer to lunch now, I thought it would be appropriate for the third story to be about food. I'm seldomly watching TV nowadays, but for some reason, every time I do, I seem to end up in looking at this cooking TV show called MasterChef. I don't know, maybe Gordon Ramsay is nowadays in every TV show, but maybe it's just only me. Anyway, in this TV show, the contestants have to cook stuff out of quite strange ingredients often, like testicles or chicken feet or something similarly obscure. So there was this episode of where one of the contestants, a girl named Diane, not in this picture though, was struggling to cook dish from tripe. So most of you probably think, what the hell is tripe? So apparently it is a part of animal stomach. If you ask me, completely inedible, of course, but it's just a matter of taste probably. Like average person, Diane, of course, had never cooked tripe before, but she has to do something because it was contest, and she had to perform. So she improvised. She did her best, and within 45 minutes, produced really nice-looking menudo from it, at least in my opinion. So again, what is menudo? It's a Mexican soup made of tripe, of course, corn and tomatoes and chili. So according to Wikipedia, this dish normally takes 4 to 7 hours to cook. So, but she made it in 45 minutes. So I believe it comes as no surprise to you if I say that once Gordon tasted the food, the first thing he said was that, well, I taste some raw tripe here. And of course, Diane had to admit that she had cut the corners and that she failed. And there was drama, and Diane didn't become the next master chef. But why am I talking about this TV show? And that's because you and me, we are living in the TV show in the similar TV show daily. We often do stuff that we have not done before. We are doing it under time pressure and often do not have enough information. But apart from the TV show, where the ability to validate the ideas has been limited, in real life we can ask questions and validate our ideas. In my experience, however, we more commonly tend not to use this ability and just improvise. Maybe we are afraid to look stupid. Maybe we just don't want to bother the different people. I don't know. But the last Kaggle survey shows that almost 25% of respondents feel that their research results are not used by the business. Maybe this is the outcome of that. So validate your ideas before spending lots of time working and tuning them. Communicate. Don't be afraid to ask. It is said that the hardest thing in data science is asking the right question. I doubt that most of us can ask the right question before asking a lot of wrong questions before. So there is a cliché that data scientists should talk to data, but I think it's wrong. Data scientists should talk to people. How else would it be possible for them to find the insights that have real value for the people? But let's wrap it up. My experience in data science is really limited. Lately, I've had opportunity to talk to several data scientists from different organizations, our data science team being one of them. From these talks, it seems that a lot of problems that data science teams are facing today have been relevant in software development for decades. I think that our experience can help you to face these problems more easily. So I talked about 3 principles. These are: regularly discuss why and how you do things in your team, choose tools and practices that foster clarity, and validate your ideas before spending time fine-tuning them. These principles are obvious, but it is often with obvious things that they got forgotten. I hope that my talk reminded you to think about them in the future. But now, as the proverb goes, never stand between a hungry man and his lunch. So thank you for your attention, and take care.
We have a question about the tool you are currently developing. Can you tell more about it? Can we try it somewhere?
Good possibility to make promotion. Well, you probably saw some of it. If you were really interested, then you saw probably something already in the lobby where the Proekspert booth is. So we have demo there available. But in principle, of course, this is a tool for data scientists, as I said before, and we are solving the problem of experiment reproducibility. So in order to do that, you first have to solve the problem of experiment logging and all bit different things. So we started up actually solving this or doing this experiment logging, and this was our data science team that felt it was necessary for them. So you just when you run your model trainings, you have all the environment logged, environment and parameters and everything logged, and this allows you to do very different things about this data in the future. For instance, to choose the best model that you have, or even if you are running in data science pipelines, then one team may be generating a model which is input for another team, so they can always find which is the best model or something like that. And we try to be language agnostic, which means that you can use any coding language or any scripting language to integrate with that. We try to be non-intrusive, that meaning that if you want to use the tool, you don't really have to modify your code really that much. Well, I mean, I'm having a bit brain freeze here now because there's probably so much to talk about, and I'm starting blabbering, so maybe it would be better for the ones really interested that would be joining me afterwards, after lunch in the booth, and I can talk more. Thank you.
Yes. So if you're really interested, you can go to talk to our people in our booth, and if you would like to use it, you can just send us an email, and I think Andrus will deal with it. Basically, the question which became now the most popular one: what would you suggest as the best practice for managing a data science team of just one person?
I think that the point of the first story was that although you might be working in the team of one data scientist at the moment, if you look really to the results from the Kaggle surveys, then you see that most of the companies nowadays are really looking really hard into entering this field. So this means that the teams will grow. I mean, it was the same in the beginning of '90s in software development. When I joined, I had I was like a second year student in university, and the first thing was that, okay, now you do alone this project of ATM, or this machine that gives money. So I was, wow, what the hell? I mean, nobody's supervising, or what the hell? But now it seems that we even don't have any projects in Proekspert that involve one person. So it's just a matter of time. So I wouldn't really address this question this way, that how you manage a team of one person. So it's going to change very soon, I suppose.
And as I'm responsible for the business side, my suggestion would be just to join Proekspert. And we have a team of 165 people.
Oh, it's 65 already, okay. Good, busy.
But thank you, Andrus.
Thank you.